Welcome to Walkabout the Galaxy, the homecoming astronomy podcast where the science is universal, the opinions are personal, and this time, the original Top Quark is back. We are strange, charm, top and down, the AstroQuarks, also known as Josh Caldwell,
Addie Dove,
Tracy Becker,
and Audrey Martin.
Coming to you from the Walkabout studio at the University of Central Florida. Be sure to follow us on Instagram and anywhere else we may happen to show up, but mainly Instagram. And catch our videos on YouTube. We are at Walkabout the Galaxy. Today we're delighted to have original Top Quark Tracy Becker rejoining us back in person in the Walkabout studio. Last time, I think we figured out last time you and I were in the same room together was actually recording an episode of this in my hotel room.
Oh, yeah.
With
Bonnie
Meinke in Geneva, Switzerland.
At
the DPS EPSC in 2019.
I think that's right.
I think that was our one
wild.
episode that got labeled explicit.
Yes.
Oh, Bonnie dropped it.
Thanks, Bonnie. Yeah.
It's that Geneva water.
I know.
Tracy, what brings you to Florida these days?
Well, I'm very excited to be back here at UCF right now. I gave a talk earlier today at the university.
I know I missed it. I'm sorry. Don't have to rub it in.
It was
Sorry.
so good. It was so good. I learned so much. You missed out on a ton.
Oh.
Yeah.
It's okay. All of the listeners will get to hear everything I talked about earlier today.
Awesome.
Because the reason I'm here is that next week, the Europa Clipper mission will be launching on Thursday, October 10th is the currently scheduled date for the launch window to open.
What time?
12:31 p.m.
Eastern time. Awesome.
It's a 15-second
window. So
Okay.
we don't have to hang around there for very long. It either goes or it doesn't, and then we come back the
That's
next day
great.
if we need to.
15 seconds.
that-
Usually launch windows are like instantaneous or an hour and a half.
I mean,
or
that's
something like
effectively an instantaneous window.
that.
Yeah, I
know
think so.
It's weird that they would call it 15 seconds.
It's
Yeah.
oddly not quite zero.
Yeah. Not quite one.
It's like we can go 15 seconds, 20 seconds, forget about it.
I guess
Game over.
Jupiter's big enough that I don't know. we do have some maneuvers that we come back to Earth and to Mars before we get to Jupiter. So I'm not sure which gravity
particular-
assist
yes,
is allowing for
driving
that
it.
15 second slosh.
Well, I'm super excited to hear all about that and everything you've been up to with Europa Clipper. And our stumper today is inspired by the Europa Clipper mission because Europa is an ocean world. Mm-hmm. So the stumper is about ocean world moons in our solar system. If you could magically retrieve a swimming pool-sized sample from one of our solar system's ocean world oceans. So we got, what do we have? Europa,
There's so many now.
Possibly.
Yeah, are we counting the Uranian?
Yeah, possibly.
Ariel, Miranda.
Miranda, I think. Also, is Callisto?
Ganymede.
Ganymede.
Potentially.
Ganymede. Titan.
Yeah.
Deep in its
Triton?
interior. Something weird's going on with Triton.
Yeah.
So, but you run the risk if you pick one where we don't know for sure that you're just going to get a gigantic glob of rocky, icy stuff.
Ceres
But anyway,
also counts too.
Oh,
Ceres is an ocean world.
Ooh.
is it really?
Yeah.
So anyway, if you could get your swimming pool size sample, let's say like 100,000 liters, which moon's ocean or asteroid's ocean do you want to study, sip, or swim in? Mm-hmm. We'll go to Tracy last.
Is this like
she may be biased?
Is this like Mary Murder? Do we have to pick which one we're gonna sip, swim, or just pick one?
Pick one.
Oh, okay.
Just one. Yeah.
One will sip,
I don't
One
know
will
what-
sip, one
is
will
that
swim
one of
in,
these-
one will kill.
one will kill.
Mary Murder. Is this like one of your crazy duck goose made up
Just like
Just like Duck Goose.
made up things
Made up
that you
game.
guys make up to
Yep.
try to
Troll
play
you.
mind games
Yep.
on me?
Yep. You've never played Mary. Never mind. I'm stop because I can't say one.
MFK
word.
is
MFK. Yeah.
Acronym.
Yeah, sure.
Okay. I'm gonna go with. I don't know.
Okay.
I think
Audrey, you lost your chance.
Enceladus.
Addie gets no ocean.
No ocean.
I think Enceladus.
Audrey goes for
no
Enceladus.
offense.
Yeah.
Yeah.
But yeah.
My temptation was Enceladus, but then I was thinking, like, what about little, like, series or like cometary things? But we
Yeah,
didn't
Ceres,
classify
I didn't
cometary
know.
things because they don't have oceans, but they
Right.
do have a lot of
liquid.
water.
Yeah.
And if it got here, it would be melted.
supplemented.
Yeah. Well,
Are you going,
contain it.
Tracy? Are you going for Europa?
I think I would get kicked off the mission right now if I didn't
You're
say Europa.
contractually
I'll-
obligated.
I'll stick
Yeah.
with it.
Even if you said a different answer, we would in post put you in saying Europa to cover
But I
your
wouldn't
butt.
sip it. I think it has, hopefully it's very salty, and I'm not a big fan of salt.
Yeah,
Okay.
sure.
So
I feel like most of them are kind of salty.
they've gotta
or
be
like
salty, right?
ammonia-y
Yeah,
or something.
that's the other thing. They,
They
might
might-
have a lot of ammonia,
I'll taste it. though.
Ammonia might be stinky, but
but also not taste good and kill
and
you.
also that. If it's just salty though, that'd be great because I could float.
Yeah, that'd be fun in
right
your
up
pool.
to the ice shell edge.
No, in the sample.
Oh, right.
sample
I'm
that you
putting
brought
the
back.
sample in
That's
my
right.
swimming pool.
That's right.
That's the idea. Then I could float for the first time in my life.
So which one are you choosing for that?
I'm gonna go in your honor with Europa.
Nice. Thank you.
In honor
feel
of
honored.
Europa
In
Clipper. Yeah. Well, today we'll talk about planets around white dwarfs, the Europa Clipper mission, of course, and much more. But first, this episode of Walkabout the Galaxy is brought to you by Kepler's Laws. In a world where each day things seem to get more confusing and unpredictable, put your worries aside and invest in Kepler's Laws. Reliably predicting the motion of planets for over 400 years and available for satellites, asteroids, and spacecraft too, Kepler's Laws provide a stable foundation for your future. With 3 simple principles, you can use Kepler's Laws to plan your next interplanetary mission or your next walk about the galaxy. In less time than it takes to say p squared equals a cubed, Kepler's Laws will have you on your way to wherever you'd like to go in the cosmos. Mention code WTG for a special partner offer with general relativity for trips in strong gravitational fields. Kepler's Laws. Who's your rock?
Oh, who's your rock? Credential.
Oh, maybe.
You're right. It's definitely. Got to
Was I?
jump in. You had it.
Oh, I wanted
So
to see
just
what
like-
somebody else would come up with. Was I right?
You're right. Yeah. Prudential Financial.
Wow.
Way
They
to
got that
go.
big rock in
The
their
rock.
logo.
That's
Yeah.
right. The rock.
Yeah, that's really good.
That's going to be the best thing I did all day, everyone.
That's pretty
It's a
good.
big accomplishment.
It was.
Ending the day and the week on a high. Yeah. I think there's going to be more good stuff ahead
Okay,
on this show.
great.
Starting with space news. There's
Space
some interesting
news.
space news.
I heard there's going to be some launches coming up.
2 launches.
Hopefully.
Two of them.
I think more than 2 even,
Yeah.
depending on how far out we go. Which 2 are you
One-
talking about?
1 week.
On Monday is the Hera launch
Yeah.
on a Falcon 9.
Yeah, we
Oh.
mentioned this last time.
That's the ESA mission, the European Space Agency mission,
Right.
heading to visit the asteroid that already got smacked, darted
right.
into.
Now,
The
now it comes back.
Yes.
Yeah. So Hera will go check out how Didymos is doing
And Diddy Moon.
and Didymoon.
Or Dimorphos.
Right. Yes, we talked about that on our last episode.
Yes.
That's coming up
Monday.
On
at
Monday.
10
And also on
a.m.
Monday.
from here.
From
Yes, from here.
Awesome.
Kennedy.
Also on Monday, potentially, is the next, as an just announced, New Shepard, Blue Origin New Shepard suborbital launch with no people on. It's a crew capsule, but not with any people on board because it's the first time for this capsule, so they're certifying it. So it'll have a bunch of experiments on board.
Is it a new booster also? I kind of inferred that it was, but I'm not 100% sure.
Great question.
But this is at least a new capsule and possibly a new booster for their passenger tourist flights to suborbital edge of space flights, according to them, to meet demand.
Yes.
So that'll be interesting. They've had a much slower launch cadence than I thought they would, given how reusable that vehicle is. And it's like, goes up, 10 minutes later, it's back down. It's like, wheel it back.
Well, how much are
Tank
the
it up.
tickets?
Well, they're
That's
out
unknown.
of our price range.
Maybe out of a
I
lot of
think they
people's
did
price
recently
range.
just say that they were selling more tickets, that they had reopened ticket applications.
Right. But they're not like saying X
How much they
dollars.
are.
Yeah.
Do you think the driver is the cost and therefore the demand, or is it just that they have to like
I think it's
tinker
process
around with it afterwards
and
and make sure?
prioritizing how much they're putting into that
Yeah.
whole project,
Yeah.
maybe. Yeah.
Yeah, it's a little confusing because the picture, the word descriptions in the thing I read talked about the capsule. So the new capsule is named RSS Carmen Line.
Yeah.
But the pictures that show the new human rated vehicle is the booster.
Right.
So I'm a little unsure if
yeah.
it's the whole thing or just one half.
If it's a new booster or just a new
They did.
capsule.
I think they did need a new booster in operation because they blew one up recently. So probably it's a new booster also.
Yeah.
Exciting.
Good reason.
So that's potentially going Monday, which will be in the past when this podcast airs. That's for Monday the 7th.
And that's out of Texas?
West Texas. Yeah.
Far West Texas, near Van Horn. The successful test flight of the Vulcan Centaur occurred.
Mostly successful.
Okay, fill me in.
There was, so the you described the rocket.
I said the words.
Yeah.
Vulcan Centaur.
That one launched from KSC this morning.
Yes.
This morning.
Oh.
I didn't get up in time. I forgot how early it was, so I didn't watch it. I was
Me
I'm
neither.
going to see it. And I think it went and they got the vehicle to orbit, but there was some issue with one of the SRBs. And in like some of the pictures, you can see some extra explodey bits, and then the ones after that, there's like the trail from the one SRB is less than the trail from the other SRB.
Interesting.
So it
Explodey
was-
bits are not usually what you want to have in your post-flight report.
Yeah. So I recently met a person whose daughter also goes to daycare with my daughter, and he does space launch photography.
Oh.
So he like does rocket photos and stuff like that. So I was looking at his photos earlier on Instagram.
Pretty amazing.
And they were super awesome.
I will say one of the things I miss about Florida, besides hanging with all of these fine people here, is the fact that there are so many launches that you just like
Step outside.
didn't get up for
missed
that
that
one.
one
But
today.
there'll be 4 others before
Within
the month
next-
is over.
Right, yeah.
Yeah.
I do miss that. There are lots of times where just I'd be driving somewhere and I'd be like, oh, hey, there's
rocket.
a rocket in the
Yeah.
sky.
And the pace has picked up significantly
believe
since
it.
you
Even
left
since you
here.
left, yeah.
I believe it.
Yeah, it's become kind of just a thing that happens
That's amazing.
regularly. Yeah. Let's see.
Is there any other
The only
missions we were going to talk about?
I
Clipper.
have something that'll sort of lead us into a little topic, and then I'll drop your trivia, which is historical space related,
Great.
Okay.
and then we can grill Tracy about what she's been up to all these years.
I'm ready.
She's ready. This is a JWST, I believe, observation of a gravitationally lensed Type 1a supernova that took place when the universe was a wee lad of 3.5 billion years old.
Oh,
cute.
just a baby.
Just a tyke,
It's like
which
Finn.
gives Type 1a supernovas are a standard candle. So they're super important for measuring the expansion of the universe. And when if you're the OG top quark, what is Jim Cooney?
The lame replacement. Just kidding, Jim. We love you.
He's
He's
anyway.
the population 2 top quark.
Yeah, right.
Type 2.
Population 1. Which way does it go? I always forget which way
The
it goes.
bigger number is younger.
Yeah,
So,
so
Tracy's like pop 2.
2. So Jim's pop 1.
Pop 1 top quark. Kind of has a little ring to it.
does.
I kind of like
Pop
it.
1 top
Pop
quark.
1 top quark.
I'd pop it.
And
No, no.
and he is a pop.
That's true.
Yeah. Anyway, as we have discussed many times with Pop 1 Top Quark Jim Cooney, there is this thing called the Hubble tension, which is a disagreement in the value for the rate of the expansion of the universe, depending on which approach, which set of data you use, like nearby and extrapolating to the distant universe and therefore the past, or sort of distant cosmological data and extrapolating that back towards the future, and they don't really agree very well. So people are excited about this one potentially helping to resolve that. But it's like, okay, they have this, it kind of is interesting. The paper is still in peer review, so it's not published yet. But
So it might all be fake.
it seems, did I say it seems?
You did.
That's weird.
That is a weird way
I
to
wonder
say
why
it.
that happened. It seems that the value for the Hubble constant derived from this is consistent with the local measurements.
Okay, that's
Even
good.
though it's a distant
That's
measurement.
That's good.
So it's interesting.
Oh.
Unify it.
Yeah. Yeah.
All right.
So that was my segue to our first mini science topic.
Great.
Yeah. I'm going to take
Oh,
my
that
headphones
wasn't the
off because I
science
don't actually
topic?
need them. It's making me sound very echoey in my head.
I know.
No, the science topic is a white dwarf planet.
Oh,
A white
Wait.
dwarf
A planet around a white dwarf?
Yes.
Or a white dwarf that has life on it that we've discovered?
That would be...
Wow.
That would be
Europa,
pretty cool.
take a back seat.
There's a book that has that. The Dragon's
Egg.
I
It's
read
a
that in
neutron
college.
star.
Oh, Neutron Star. You're right.
Yeah, by Robert L. Forward.
Yeah.
That's a cool science.
Yeah.
Hey,
Oh, Josh is so
Sci-fi
glad to have Tracy back.
that was cool because like their whole life thing was like very, very fast compared to ours because gravitational time dilation. They're like...
So they send a message to the Earth, and the Earth would take like what felt like a day here, but it was like a 70-year.
It was like generations
so they'd have to pass
for them.
the generations.
Yeah.
Yeah, very cool.
It's like a Star Trek with the planet that pops in and out, and they have generations that pass.
Yeah. In any event, this is neither of those things.
Nope.
It's a planet around a white dwarf, and it was discovered. Those are tricky to see because most of the exoplanets that we see are through transit or radial velocity measurements, and you're not going to see that with a white dwarf, or it's too small, too dim, or not bright in the right wavelengths. This was seen by my favorite thing ever, technique for seeing things.
Oh,
I don't.
Addie knows it.
I do know.
Yeah.
Is it the wobble?
No.
Blue shift?
No.
Gravitational and microlensing.
Oh, well, that makes sense.
So this was observed through gravitational microlensing a few years ago, and the new paper by Zhang et al. At University of California, San Diego, took a look at it together with Zhang et al., the original 2021 discovery. So they determined that the planet is about twice the mass of the Earth, so probably a kind of terrestrial-ish style planet.
Wow.
Okay.
At a distance of 2 AU from the star. So the press stories about this have to, and the original star was probably like the sun.
Yeah.
And the press stories are about like, okay, what does this say about the potential ultimate fate of the Earth? Well, 2 AU is out past even Mars. But the cool thing is before the star goes white dwarf, it swells up, which potentially then engulfs all the inner planets. Mm-hmm. But as it swells up, it loses material, and the star then is getting less massive. And if the star is less massive and you're zipping around it at the speed you need to be orbiting a more massive planet, your orbit expands. So as the star dumps mass, the planets can migrate outwards. And by their estimation, this planet probably was at 1 AU.
Wow.
Whoa.
Before the star finished its, dumped all its material and ended up just
How long
with
does
a
it
white
take
dwarf.
to migrate from 1 AU to 2 AU?
It's
got to be a pretty slow process, right?
Yeah.
Well, I guess it
it's
depends
like
on
a-
however fast the mass is being shedded.
Yeah, but it's like a momentum, like it's a
It has
momentum
to be-
exchange, right?
Yeah,
So it's got
it has to be on a
relatively-
time scale that's very long compared to the orbit period.
Yes.
So, 10 to the n years, where n is
Yeah.
more than 4 or something like that.
Okay.
The red giant phase is millions of years, I think, for a star like the sun. Waving my hands and making nervous expressions because I don't really know exactly how long it is, but it's slow enough compared to the orbit period that you can have that sort of adiabatic expansion of the planet's orbit. So the Earth may not get
I feel like I haven't
incinerated.
seen much modeling about that before. About that
I haven't either.
angular momentum transfer and
Yeah.
expansion.
Yeah.
And maybe
Because
it was
we always talk
because
about
they-
how when the sun goes red giant, we're going to get swallowed up, which will still happen. We're not saying that won't happen.
No, we're saying it might not happen.
That's what I'm hearing.
But when it goes red giant though, it's like it's expanding and it doesn't have the same.
What's the rate of
So
expansion?
But it doesn't lose mass the same way.
This is the punchline of the study is the suggestion that this planet may have evolved out and avoided
that
Right.
demise.
that demise, and therefore the Earth might also avoid that demise.
Were there other planets in the system?
Who knows?
Oh, because of yeah.
There is, interestingly, and confounding the conclusions, a brown dwarf orbiting this white dwarf. So the brown dwarf is like a star that was too small to become a real star.
How far out is it?
22 AU.
Oh, that's so close.
Right.
I was expecting in the hundreds.
Right.
Okay.
So it's like the distance of Uranus or so. So everything is a little
What
bit
an
weird.
exciting system.
It's interesting. Yeah. So, and I hadn't thought about that sort of like planet migration thing in those.
Yeah.
So, yeah. So we won't be around to see that probably.
Well, you never know.
Unless we like get on some very close to light speed ship very soon and spend some time going 99.9999999% the speed of light for a while.
Or we freeze ourselves until the moment that the sun goes so giant that it warms us back up.
Yeah.
Before the planet escapes.
Those are the two
perfect.
equally likely options that we can pursue for that. Okay. Well, before we let OG Top Tracy tell us all about her amazing mission, and I just refer to this as your mission now. I say my former graduate student Tracy Becker is running a mission to Jupiter that's launching next week.
Nobody will be upset about that.
No.
Nobody I talk to is upset about it. Everybody I talk to about it is really pretty psyched.
Oh, yeah, that's awesome.
They're pretty pumped up about it.
Wow, good for her.
Today is the anniversary of the launch of Sputnik.
Yeah.
Oh.
Just last week was the anniversary of NASA.
Oh, really? From a different year.
From a different
later
year.
Sputnik
60.
was launched on October 4th, 1957. You have two little simple multiple choice trivias about Sputnik. The first is, what is the translation of the word Sputnik?
I know this.
Your choices, do you want me to give you your choices now or
yes.
wait?
Oh.
Sure.
Okay, your choices are satellite, little star, little friend, moonchild, or starchild.
Okay.
There's one remaining piece of Sputnik 1. So it was in orbit for a few months. It was in communication for a few weeks. Eventually, orbit decay, satellite lost. But there's, we have these removed before flight red tags, which now are sort of like an obligatory fashion accessory for those of us in the biz.
Yeah.
Do you have a remove before flight?
I don't.
Oh, Tracy.
Never put it on your luggage.
I'm so
that you check.
Oh, really?
I've had people tell me they've had them taken off
because it's
because
going
it
on an
says
airplane.
remove before flight.
So these are things for spacecraft. It's like the lens. You don't want to leave the lens cap on your cameras, on your spacecraft's camera before it goes to Jupiter. Yeah. So you put a big red tag on it that says remove before flight. Also, when you buy a toy USS Enterprise that has batteries and lights and things, and it's got a little plastic thingy in there to keep the battery from discharging through the circuit when it's in the store. Then when you get it home, you remove it and it's good to go. Well, Sputnik had one of those. Had a little tag, a little metal tag that you pulled out before flight that enabled the batteries to talk to the transmitter.
I have mine from my CubeSat.
That's awesome. Yeah. Aww. So that is the one remaining piece, one could consider it that way, of the original Sputnik. And the question is, where is it?
Oh.
Is it A, in the Cosmosphere in Hutchinson, Kansas? B, the Energia Museum in Moscow? C, the Smithsonian Air and Space Museum in Washington, D.C.? D, the NASA Johnson Space Center Visitors Complex? Or E, the Museum of Cosmonautics in Moscow? So we'll come back to those at the end of the show. And
On my back.
Oh, sorry. I thought you were commenting on the trivia.
I'm thinking.
Okay.
I feel like if I get these wrong, I'm going to be really upset with myself.
First question I have about Clipper.
Yes.
Tell us about the trajectory. Launch is next week. Mm-hmm. Then what are its stops along the way to Jupiter, and when does it get there?
Yeah, so launch window opens October 10th, and then it does an Earth flyby and a Mars flyby. And I believe this is the first Mars gravity assist that's ever actually been used, because generally Mars isn't that large of a gravitational
generally not,
support, but it was the way to help this particular spacecraft get out to Jupiter.
Yeah.
So arrival Jupiter orbit insertion will be in April of 2030.
Are those the only two assists? One Earth, one Mars?
I believe so.
When is the Earth flyby, did you say?
Maybe there were two Earths. I don't remember, actually, the dates. Sorry.
I'm going to fact check your Mars flybys.
It's your mission, Tracy. How could you not have these
One
things?
of the Earth flybys is very close to my birthday, but I don't know what year. So December-ish, sometime between now and 2030.
Something is happening in December in the next 5 years. Okay.
That's right.
So, and then it gets there in 2030 to
Yes,
Jupiter.
April 2030.
Okay. And then Jupiter orbit insertion, goes into orbit around Jupiter,
Yep.
and then with how many flybys of Europa planned
The planned prime mission is 49 flybys.
over a period of
About 3 years.
3 years.
3.5 years.
Nice. Okay, great. Yeah.
Are you going to fly by any of the other moons? Like, just for fun during that main phase?
Yes. Not just for fun, but
But it's not like
Just for
the
funsies.
main, like the priority.
in fact, because the mission is very focused, it's a Europa-only mission, we will use Ganymede and Callisto to help orient the orbit and change up the orbit when we're ready to go in different directions. And those are, we can possibly use them as calibration targets.
But you can't
Nice.
learn anything about, not allowed to learn a damn thing
At
about
this point in
Ganymede or
the mission,
Callisto. That sounds.
We're not doing any science observations of anything but Europa.
Right. Yeah.
I totally,
Yeah.
I can totally see those conversations and emails and memos. It's like, yeah,
But so we'll get pretty cool
you
data.
better not learn a damn thing about those other
Yeah.
objects because that's not what we're paying you to do.
That's what happened with Dinkinesh. We flew by it and they were like, don't do science.
Yeah.
Don't you dare do science.
But
Yeah.
you did science, right?
Yeah, because I don't get paid
You
by
don't get
it.
paid by it, so you can do.
I can do science.
So that
okay.
data is available now.
Yeah.
So
Yeah, the
other
data-
people can do science
yeah.
with that data.
The data
very
are
good
all
point, Ed.
available.
Yeah.
The
I
data
am-
will become available.
I'm not a
thing,
co-I.
so the thing we're all sort of talking about is that like when a mission is funded, it's funded to do specific things, and you have like mission deliverables and objectives and like baseline things you have to do, and you have to like meet that mission. And then there's all this other awesome stuff you're gonna get out of the mission, and you know that, and like everyone else knows that, but you can't say that because A, if you don't get it, then it makes you look bad, and B, it's not like what the initial funding was for.
Right.
Yeah, so you can't spend resources on learning from it.
It's the
Yeah.
the
At
this
resource
stage,
part
yeah.
is a big thing
Yeah.
because then they're like, oh, okay, well, we got a budget cut. And you're just like, well, we can't cut the budget. And it's like, yeah, you're doing science at Callisto and you're not supposed to be doing science at Callisto. So cut that part. And it's like, oh, it's not really for science, which it isn't.
No.
You need to do it for these other things. The same thing with Cassini, with Venus and Jupiter flybys. And Jupiter really was a practice exercise for Cassini. So, yeah.
And then all of the data from NASA missions becomes publicly available.
Right.
And so then folks can do whatever they want with that,
Right.
and often do.
Armchair
And even
planetary scientists.
yeah,
And,
or funded planetary.
yeah, and apply for funding.
Yeah.
Right, yeah.
And later apply for funding to use that data.
From separate sources, right.
Yeah. So there will be definitely flybys of Callisto and Ganymede that we can
And just
That
to
will do some-
situate
The
ourselves.
the Earth gravity assist is on 12/01/26.
see. That's the day before my birthday.
Jupiter orbit insertion 4/11. That's my birthday.
Wow.
It's funny because you
My
presented
God.
earlier. You said April 2030, and I said that's my birthday, but it is.
It's literally on your birthday.
Literally
and
on
it's
my
the day
birthday.
before your birthday. Nice.
What an excellent present for you, Addie.
For both of us.
Nothing is happening on our birthdays, Audrey.
Nothing.
Sorry.
Well, the election always happens on my birthday.
Okay. Hooray.
yeah. Well,
Our very fun Cassini data of the stellar occultation that was very weird at Saturn's F ring was on your birthday.
That's true.
There you go.
so we're all special.
Josh's birthday has a
Yeah.
special thing too.
The just to situate everybody for Europa and the satellite, for Jupiter and the satellite system. So Io is the closest in of the four main Galilean satellites, then Europa, then Ganymede, and then Callisto. So it'll basically never really be venturing. As soon as it flies by Europa, it's going to be using Kepler's law as our sponsor to like get the hell out
Yeah.
of there as quickly as possible, because the sort of deeper you are closer into Jupiter, the more the radiation is a problem.
Yeah.
Which brings up the elephant in the room,
Oh yeah.
transistors.
Yes.
You want to tell us how you're feeling about the whole transistor situation?
Sure. There was a New York Times op-ed that talks about the whole story of it. So if people are interested in it,
It
they
was
can read
interesting.
it.
Yeah.
Yeah, it was one
Was
of
it
these.
accurate? And
Yeah, to my knowledge.
Yeah.
And it was very much in collaboration with the PI of the mission, Bob Papalardo. And yeah, so only several months before.
Bob is the project scientist, probably.
Sorry, yeah, project scientist for the mission. A few months before launch, it was discovered by a non-NASA a company that these resistors that are throughout Europa Clipper.
Transistors.
Sorry, you're right. Transistors. Thank you.
Are you sure you're running this mission?
Definitely not. These transistors were not as radiation tolerant as they were expected to be, or that they thought they would be, at least for this mission.
Right.
And after a whole bunch of testing and probably a lot of panicking at levels of the people who are running the mission, they were able to do an amazing coming together of the engineers on this. Like engineers at JPL, at APL, at all the different NASA centers, did a significant amount of testing and discovered that we should still be in the clear, that it was kind of a scare.
One of the interesting things I learned from that New York Times paper was that there's some like annealing or sort of healing that can happen if there's a defect that is caused by a radiation impact. The basically atomic scale material properties of the transistor can evolve so that then it can work okay again.
Yes.
And part of the question was, will we be able to determine that these things have happened and then rearrange our sort of software and our operations to enable that annealing to take place? I don't know if they described that very well.
Yeah,
but
and so one of the ways they're doing that is that they did build, in that very short period of time before we had to get out to the gate,
That's right.
They built a canary box.
A witness plate.
Yeah, they're calling it a
basically.
canary box. So they put the different types of these transistors, they're called MOSFETs, on the spacecraft in a way that we can monitor those. And so if we do see a surprisingly or alarmingly fast degradation, we can then make some decisions, on that specific one.
transistors.
Because the rest of them we didn't design, they're not designed to tell us what's going on with them.
Right.
So, but these ones will.
Yes, that was the amazing thing. I
Yeah.
was super impressed
So
by
in a
that.
couple months, again, the engineers that come together and like were able to build this thing, test it, make it flight ready, put it on the
Right.
spacecraft, adding mass in a different place, making sure
Right.
everything, all of that had to be accounted for in this very, very short period of time. So heroic levels, I'm sure there'll be like a cool documentary about this process that happened in the last 4 months.
Yes, they're going to get some nice certificates.
Yeah.
They can put on their wall.
appreciation. They could
For
put on
working
their
24
wall
hours a day for the
to
last 4
save-
months,
to
here's
save the
their
mission.
certificate.
Because years and years and years of very careful, deliberate assembly and testing take place for an interplanetary mission like this, because you can't, it's not like, not to say that there wasn't also years and years of deliberate testing for Hubble, but we could go up and kind of fix Hubble when there were issues, and that's not an option here. And so to be able to like design, build, and integrate an actual entirely new component of the spacecraft that was not planned for at all is pretty amazing.
Yeah. And again, all the testing that they had to do to make sure that, what we have right now, we're expecting will work fine in the Jupiter system.
Well, tell us some about what we are going to learn from the moon. We are allowed to learn something about.
Well, Europa is an ocean world, as you said. And we know that basically mostly from gravitational measurements or magnetic field measurements that were made with the Galileo spacecraft in the 90s. And so what happened with that spacecraft was it had a magnetometer and sensing the very, very strong magnetic field at Jupiter. And then as it got close to Europa, it sensed an induced magnetic field. And that induced magnetic field could only be due to some sort of a conductive layer, so which led us to the very likely hypothesis that there's a liquid water ocean with some sort of salt level. And so with Europa Clipper, the primary goal is to assess the habitability. And part of that will be, where is that ocean? How deep is it? How cold is it? What is the salinity levels? And are those the types of conditions that we understand to be able to support life as we know it?
So how since that ocean is buried, how are you going to do that?
Yeah, so we have a suite of very powerful instruments, some of the most, modern, exciting instruments that have ever been built to go on the spacecraft. And some of the ways we do it are just by looking at the surface and the atmosphere, because we do believe that there are mechanisms for that underlying ocean to get to the surface. So we see these cracks and these sort of discolorations along those cracks that might be signatures of material coming up to the surface and refreezing.
I mean, it has to be coming up somehow. There's not craters there.
Right. That's the other main thing. We know that there's some sort of geologic resurfacing happening because it really is a generally pristine surface very few craters. And so there's no reason for Europa to get hit by fewer craters than the other moons.
Right, yeah.
So it's some sort of resurfacing like we have on Earth that kind of erases everything.
And unlike, we've talked about Enceladus a bunch in the past, and Enceladus has geysers, which are the steaming gun, if not a smoking gun, of liquid water underneath its surface. And it's got a regional area that's young, resurfaced without craters. But in the other northern half of the moon is heavily cratered like you would expect to see. Europa kind of like there's no craters really anywhere on Europa.
Yeah, there are very few.
Yeah, right.
Yeah.
Yeah, there's some, but
Yeah, and so, right, we think
just like there's a few on the Earth.
Yeah, there's some sort of global reprocessing. And even if there might be plumes on Europa, they don't seem to be nearly as large. They're not creating an entire ring around Jupiter the way that Enceladus can create the E-ring around Saturn. That's partly, if there are plumes there, it could be just due to the size of Europa being much bigger than Enceladus, having a larger gravity, and therefore the material not being able to escape as far into space.
Right.
So if there are plumes, it might be a little bit more localized.
Yeah. Will you be able to see these plumes?
Oh, yeah.
Oh, yeah.
Oh, yeah.
Oh, yeah, definitely.
So the instrument that I work on, we can say my instrument. No. The instrument that I work on, when I was a graduate student at UCF, I worked with Josh on the UV instrument on Cassini.
Those were the days.
Yeah.
The days.
And so the instrument on Europa Clipper that I work on is the UV instrument, the Europa ultraviolet spectrograph. And the first putative detection of plumes or water geysers at Europa were made with the Hubble Space Telescope at UV wavelengths, where they saw a coincident amount of hydrogen and oxygen emissions in the same localized region off of the edge of Europa. And they were at the right ratio to be two H's and one O, basically emitting like an auroral emission type signature. And so that was sort of the first detection of a possible plume. And so we have a UV instrument on this mission, and it's sort of dubbed the Plume Hunter. And it will look using that same technique. Look for plumes that way. Also look for plumes doing stellar occultations, so watching a star go behind the planet or the moon, and see if there's any kind of change in the atmosphere that might be indicative of a recent
that worked
eruption.
with Cassini as well at Enceladus, and it was not really a. Well, we got an amazing confirmation of the composition from looking at the spectrum of the absorbed starlight.
Yeah.
So, yeah.
Yeah, and at Enceladus, we didn't really do the emission side of things because it's really uniquely to Jupiter's intense magnetic field that's breaking up any of the water molecules in the atmosphere and allowing them to have that emission signature.
Okay. Yeah. Cool.
Yeah. So hopefully we'll see plumes that way. Yeah. If there are plumes, we have two instruments that are called in situ instruments. So one is a mass spectrometer that was also built at Southwest Research Institute. And that can basically smell, we say, the atmosphere or a recent plume emission. And SUDA, which is the dust detector from Addie's old stomping grounds, University of Colorado.
Woohoo.
And mine.
And
Josh's. Sorry, yeah. We're all from the same places. And
is Sasha Kempf the PI of that?
Yes.
Yeah. Nice.
Yeah, and so that can collect the actual dust or ice grains.
Particles,
and tell us the composition
how close will Clipper come to the surface of Europa?
25 kilometers is our closest flyby.
Of the 49 that are planned so far.
And we have many 25-kilometer ones.
A lot of them at that distance, and then
some are
others,
at 50, some are at 35, some are at 100.
Okay, but they're all sort of vast majority less than 100
The
kilometers.
vast majority are 100 or less. There's a couple that are just higher up based on the geometry of the flyby.
The orbit and where you need to go next and that kind of thing. And what kind of coverage will you get of the surface of the moon?
So we have some requirements in terms of how much spectral information we'll get in the infrared. That's one of our key sort of compositional signature detectors. And something like 70% of the surface imaged in the infrared at, I think it's under a kilometer resolution or so, or maybe less than that.
Okay.
So really high resolution and with spectra. But the cameras will take even better images, higher resolution, and probably more globally because they have a pretty large field of view.
Okay.
Do you already have the specific locations planned out that you're dipping in close?
Yep. Everything is pre-planned.
It's locked in pretty much.
Yeah. Oh, wow. Yeah.
For a four-ish year mission.
Yeah, 3.5 to 4 years.
And then you have plans for extended missions.
Yes. Well,
Yeah.
There will be plans.
There will be plans.
Probably not allowed to start
They're not
spending
allowed to plan
resources
yet.
on that now.
yeah. But yeah, so for the prime mission, we'll get at least 70% coverage at really good high resolution spectral information in the infrared to get get at the core of sort of the non-ice material that's there.
So right now, it's a 5.5-year tour.
No, it's a 3.5.
No, to get from, sorry. Interplanetary,
Yes.
to get from here
Which
to there.
actually, like, when it says, it's getting there in 2030, I've always been like, that's so far.
long.
But 5.5 years isn't that long to get out there.
If we'd gone on the SLS, had the SLS been ready, it would have been a direct route. And it would have only been
Really?
4 years.
Yeah.
Oh,
No
well.
flyby.
Yeah.
One less
That's
trip
only
around the sun,
Yeah.
basically. Yeah. I'm kind of amazed.
Is that much more powerful?
SLS
If it ever is.
than a Falcon
real.
Heavy.
Yeah.
I mean, SLS exists, but not in the configuration they were going to fly, I don't
Yeah.
think, actually.
I see. Yeah.
Yeah. Because I think that would have been a future block. Like, there's different blocks
Right.
of SLS, and I
Different
think that there's one
configurations.
more that they have to test.
Yeah. Okay. Audrey. Yeah. I've been dominating the questions, but maybe that's because I didn't go to Tracy's talk.
We learned everything.
Yeah,
You already
we
know
know
everything that's going on, but do you
everything.
have follow-up questions
Are
from that?
you particularly excited about exploring like a specific region of Europa? Like, are there certain bands in one place that are like really interesting or really mysterious that you're really stoked about?
Yeah, I think some people are really excited about the parts called the chaos terrain, which I talked about a little bit. It's just a great
course.
name. But these are regions where the surface is mostly smooth. It has these kind of lines across it. And then all of a sudden, there will just be this disruption in that sort of line. That's some sort of geologic event line that's kind of a crack in the surface. And then all of a sudden, that line gets all jumbled. And so we know that this is a more recent activity that's happened there. And it's probably some sort of hotspot of water underneath that's allowing these icebergs to maybe flip over or twist or do something. So it's definitely an area where maybe some of that water underneath is getting to the surface. It's also very specific composition there and a discoloration there compared to the rest of the surface too. So that's a very exciting one. Me personally, what I'm most excited about is the fact that Europa looks like water, ice, at infrared wavelengths and at visible wavelengths. It's very shiny, very bright, very reflective, looks like an ice rink. And all the wavelengths except in the UV. In the UV, it looks nothing like water.
Interesting.
And we think it's because there's some sort of a lag deposit of material, maybe the irradiation of the water itself, and then whatever else is sort of in there becomes very UV absorbing. And instead of this sort of very, very bright reflective surface all the way out into short energies, short wavelengths of light, it just kind of drops off a lot faster than it does
At
in
a
the
longer
laboratory.
wavelength?
Yeah, it starts dropping really the UV almost has no reflectance at the Europa surface.
Oh.
But what that means is that, and it's true of both hemispheres, the darker trailing hemisphere, which has a lot of like IO contamination, and the brighter, more pristine water ice on the leading hemisphere.
Yeah, I was gonna ask if it was
Both
like
of
maybe
them
an
do
IO
it.
thing.
It's worse on the trailing, but both of them lack this obvious UV sort of brightness that should be there. And so what that means for me, I think, is that as we make these flybys, if we do spot a small region where suddenly it looks like water ice, that could be a really
Very
cool way
recent.
to see a recent plume.
Yeah.
Or a recent, like a plume deposit.
Right.
So some of that fresh water making it to the surface hasn't had time to be irradiated. Maybe that will be a great way to find where there's activity going on Europa. So that's what I'm most excited for.
That's so interesting. And it's interesting that in the other wavelength regions, whatever it is that's there, you would think that you would be able to see that extra stuff at the other wavelengths. So it's like very mysterious.
It's clear to those other ones, and it partly has to do with because different wavelengths can kind of probe slightly different
Oh,
regions.
so it might be a very thin.
Exactly.
Right.
It's very thin UV absorbing material at the very top layer.
Right.
Then the infrared can just go right through it and doesn't
Right.
even see that.
Right.
Yeah.
Before we test your Sputnik historical knowledge, Tracy, I'm going to put you on the spot. Do you have any hilarious behind-the-scenes anecdotes from your years? How long have you been working on the Clipper mission?
8.5 years.
Okay. Is there any hilarious story that you can embarrass one of your bosses or supervisors on the mission?
Probably, but I don't know about on the spot.
Not on the spot.
No, I don't know.
I mean, like, I worked on Cassini for 30 years, and I can't, like, on the spot, I can't
But you have one that you're going to share anyway?
No. I'm like, what? There were some. Most of what I'm thinking of, most of what comes to mind are like very testy exchanges at meetings between. Yeah. So
about science or
Yeah. Yeah. About like, what are we going to look at this particular time? And, sometimes it's like, you could parody it as like kids fighting over my turn to play with a toy kind of thing. It's like, no, I want to look at this thing. You already had a chance to look at your thing, and now it's my turn to look at something.
So maybe this is relevant to that then, but there is a person, and now I can't think of the title, who studied the team dynamic, a sociologist that studied the team dynamic of Cassini and
Yes,
wrote a
I
book
remember
about
her.
it.
Yeah.
Yeah.
She wrote her dissertation on that.
And she has been working very closely with project leadership of Europa Clipper to sort of make sure that kind of thing doesn't happen.
Oh, God.
Wait, what happened?
That makes me feel so bad.
What? Why
'Cause I
was it
honestly
so
felt-
bad?
Well, I mean, no, it really wasn't. I mean, it was really...
Depends on who you talk to.
Oh, well, there.
Okay, maybe I should read her
you should read
dissertation.
her dissertation.
Yeah. I think I even have a copy of it, but okay, well...
There's a big focus on team, like it's a one-team mission. And
Right.
so fighting over resources doesn't get you more information about Europa Clipper. And by
Over
resources,
Europa.
we mean,
Yeah.
whose instrument gets to point or take more data and
Right.
things like that. So the goal is to understand Europa first.
Right.
And so one of the cool things about the mission is that you have all of the instrument leads, but you also have leads of the working groups, and they sort of are at
Yeah.
the decisions that go into all of the planning are joint with the specific science working group leads as well, which rotates. Those rotate in leadership position. And so all of them come together if there is going to be a decision. The other nice thing about Europa, though, Europa Clipper, that Cassini had to contend with is that we're all co-bore sighted. So all of our instruments are looking in the same place. We didn't have a scan mirror that broke.
Well, so Cassini's instruments were bore-sighted. The difference between Cassini and Europa Clipper
Another one, yeah.
is that Cassini, you're looking at one object.
Yeah.
The mission is look at this one moon.
Yeah.
Cassini was look at Titan, look at Saturn, look at the rings, study the magnetosphere, understand the atmosphere, look at all the icy moons. So in defense of Cassini, it was a little bit more naturally competitive for the resources.
Everyone were very excited about their the science that they were focused on. And
Yeah. Well, what does Sputnik mean? How's that for a segue? Does it mean A, satellite, B, little star, C, little friend, D, moonchild, or C, star child? Tracy Becker.
I think it means little star.
B. I think that's what I was going to go with. I wasn't even cheating.
It's either B or C.
Yeah. Little star or little friend?
I'm going to go with C because they went with B.
Well, guess what? It means satellite.
No. Really?
Yeah.
Very straightforward. That's very USSR, though, right?
Yeah.
It just means satellite.
The satellite is called satellite.
Yeah, it means satellite.
The very first satellite called satellite.
The word was actually coined before the space age from S for something plus Sputnik or something funny like that. Okay. I don't know. But anyway, there's one remaining piece of Sputnik 1. Where is it?
I'm going to be sad if it's not actually in Russia somewhere.
So those are two of your choices, the Energia Museum or the Museum of Cosmonautics, both in Moscow, NASA JSC, Smithsonian, or the Cosmosphere in Hutchinson, Kansas.
Well, Addie worked at the Cosmosphere.
I did.
Yeah.
Was it there?
Did you see it?
So the Cosmosphere has an engineering flight model of Sputnik 1 and something up from Sputnik 2, but I don't think they have that thing from Sputnik 1. They had like a hanging flight that was like the engineering backup, I think, for Sputnik 1.
That is absolutely correct. That was going to be like my extra follow-on trivia.
Well done.
Is
tell you
the
all about-
home of the backup Sputnik vehicle is the Cosmosphere in Hutchinson, Kansas, which is why
Which
that's
is a
included
Smithsonian
on the
affiliate
list.
museum. So my guess is the Smithsonian,
Interesting.
but I think it's probably in Russia.
The first Russia one, you said.
Okay.
Yeah.
And I'll go with the cosmonaut.
It's at the Smithsonian National Air and Space Museum, the little
Oh man, that was
How do
my
you
third
think-
choice.
How they get? Why is it there?
Yeah.
I don't know. I don't know the
Seems-
history of how it got there.
Especially considering the history of that time.
Yeah.
Yeah, wait a
Say,
minute.
the cause has like
The cause. That's what they.
cause.
That's what those in the know calls the cosmosphere.
yeah, they have a huge, awesome collection of Russian artifacts, and I think the largest collection of Russian artifacts outside of Russia.
Yeah.
Of like space artifacts from that time period.
Oh,
Yeah.
why?
It's super
just
cool.
just that's where
It's
they
just a
ended up.
really awesome space history museum.
nice.
Yeah.
They have like V2 rockets from the Germans, and it's
cool.
a really awesome museum.
While it may have felt like waiting for Europa Clipper to launch, it was just another episode of Walkabout the Galaxy.
Be sure to follow us on Instagram and YouTube. You can contact us at wtg@ucf.edu.
Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger.
Thanks to our listeners in San Antonio and around the world. I'm Tracy Becker.
I'm Josh Caldwell.
I'm Addie Dove.
And I'm Audrey Martin.
We're the AstroQuarks signing off until the next episode of Walkabout the Galaxy.